it's a good idea if we start where it originated from, and I think you'll find it very interesting. It was actually NASA that first investigated the effects of lumbar decompression on vertebral discs. In fact, it was space travel that led to the advancements in technology that enabled us to recreate the effects of anti-gravity here on Earth. During the manned space flights, it was discovered that the actual discs increased in height as a result of anti-gravity effects. Here on Earth, we have the effects of gravity. And so we've got this pressure building on our discs in normal life. And then we age, and then we have overexertion, strenuous movements, sometimes accidents happen. And now more and more pressure builds up. And the pressure, it can cause discs to bulge, even bulging discs. More pressure can actually cause a rupture or herniation of the disc. The pressure literally degenerates the discs. Can lead to facet syndrome, can lead to sciatica. Low back pain forces many, many people to go to the doctors, to go to the hospital. In fact, it's the number one reason people visit a neurologist. It's the number one reason people visit an orthopedist. And it's the number two reason for hospitalization. It's virtually an epidemic in this country.
This represents a disc as it is deteriorating, with the disc bulging at the posterior. In this axial view, looking from the top down, we see disc herniation and pressure severe enough to rupture the outer bands, producing a full-blown herniation with pressure on the root nerve. Now, as a result of decompression, we see the herniated material being drawn back into the disc. As the herniation is being drawn back in, the disc height increases as it is restored. Another look from the top view shows the herniated material being drawn back in and new cells called type 4 collagen attaching themselves to the torn fibers, reconnecting them and making them stronger than before.
We're all familiar with airplane travel and the cabins that are pressurized. So picture an airplane and picture a pressurized cabin. Now picture what happens when a window is broken in the airplane. All the contents of the plane is going to fly right out the window. That's because outside the airplane is negative pressure. And what we do with decompression is we create negative pressure inside the disc. That negative pressure that we create inside the disc is what decompression does. Creates negative pressure inside the disc, reversing the high intra-disc pressure. But watch, as we create negative pressure, we literally draw back into the disc the contents that it may have spilled out. Just like in an airplane, when the negative pressure outside pulls everything out, when we reproduce that effect and we get negative pressure in the disc, we can draw back into the disc the discal components that have been bulged or protruded. Now, that'll bring relief, but that's not all, because we want to bring a cure to this person, and here's how decompression helps us to do that. As we draw back in the components of the disc that have been bulged out, we're also drawing back in nutrients.
Decompression also allows for strengthening of the outer ligament bands that hold the disc material in place, so it prevents reoccurrence.